So Shanya, who will talk about immersive visualization of disaster and climate risk with game engine technology, a Guatemala City case study. And looks like she's online.
Good afternoon, everybody. All right, so I'm Shanya, and I'm excited to give you an update to some of our ongoing work exploring game engine technology, of course, with the add-on of virtual and augmented reality, specifically for earth science. And a lot of this work has been conducted over the past 6 years with some support from the Earth Science Technology Office and also from NASA Applied Sciences through NASA headquarters. So wanted to kind of provide some overall context for this. I mean, obviously, NASA has a robust earth science program, and we've really been looking at how do you translate that data into something that's usable for the many outside stakeholders. And we've had the honor and pleasure to be able to represent NASA at many different earth science and geospatial natural hazards and disasters type conferences before COVID. And like all of you have also been adjusting during the pandemic to how do we continue this research and keep it going even with those pandemic limitations. So one of the benefits, I would say, actually, of the pandemic, we started getting invited to do some of these virtual webinars, and someone from Ricardo Quiroga from the Disasters Program had asked me to present in Spanish to a consortium of Central and South American countries. And that really kicked off some really interesting conversations about what we might do for a pilot project using the technology that we had developed. So this is an explanation of that project, and I have a window into how this technology can potentially find some real world application. So these are some of the project partners. We worked directly with the municipal government of Guatemala, with international groups such as CEPREDENAC and SICA, which are in part of the emergency management for Central America, the United Nations Office for Disaster Risk Reduction, and of course the NASA Disasters Program. And very special thanks to that program for their ongoing support and vision, or maybe supporting our vision of how this technology can be used to better understand and translate NASA's data sets into something that's usable to help people prepare for, understand, and recover from natural disasters. There's a lot of information out there in the world, and NASA generates a huge amount of data, whether that's Earth observation, remote sensing, satellite imagery, model output, and a lot of that lives in disparate places. It might be in different repositories. You need to know where to go to find the data. And then, of course, you combine that with all of the information that's generated locally by the state and local governments and other organizations in the form of maps, plans, etc. So how do we really combine that data to make it relevant and understandable, and at the end of the day, actionable? Because this data can potentially save lives and property and help people to make better decisions in terms of resource allocation, preparing for events, becoming more resilient, and then, of course, recovering after these events occur. I don't need to, preach to the choir about what are some of the benefits of using a game engine, but just, suffice to say that we've really been exploring how can you take all of the cinematography, the lighting effects, the realistic terrain, and overlay data onto that, or interpret the data in a way that it can help people to really visualize things that are difficult to understand. This builds on, many years of, working with this, and especially really becoming adept at ingesting this type of earth science data in a way that is not just a one-off, but is actually automated. So we have successfully connected our game engine platform, in this case, we're using Unity, to the NASA Disaster Applications Portal. This is a public-facing geospatial portal, and so we're actually able to automatically ingest new data directly into the platform. Let's talk specifically about Guatemala City. After one of the webinars that we gave, they really came forward and said, we have a multi-hazard risk analysis that was conducted for the city, And we think that it would really come to life in the game engine because unfortunately, we don't necessarily understand all of the critical information that is contained here. And, if you think about the way that scientific information is often communicated, unfortunately, it's often in this type of a format. It's a 70-page, very dense report, lots of statistics, lots of information that's critical, but not necessarily easy to understand. How does that actually get translated into something that can turn into a decision? The report also contains a lot of maps, such as this one. Salvatierra was the main organization that had conducted the multi-hazard risk analysis, and they did a very in-depth job of identifying what were the risks for Guatemala City. And when it comes to hazards, unfortunately for them, they have it all. They have seismic risk, they have volcanoes, they have susceptibility to tropical storms and cyclones, which then leads to flooding and landslides. They have droughts, they even have fires. So there's a lot going on and very important to understand. Unfortunately, when you have these type of reports and these type of maps, that can be difficult to then apply what is in the report into something that's actionable at the level of a city engineer or a mayor or someone who's making those critical decisions. In this case, our first step was to really get that type of information from the multi-hazard risk analysis document into Unity, and also, of course, incorporate relevant NASA data products. We also found out in our early meetings with the city government that they actually had 3D building models that had been generated for property taxation purposes. And so there were some additional assets that we were able to bring to the project. So that first step was bringing in the 3D building models on top of some of the Esri geospatial base maps and that 3D terrain. And then also being able to get the fault lines into their proper location, make sure that the georepresentation could be well understood. Seismic risk was one of the sort of prominent things that the city was very interested in understanding. Guatemala City had experienced a 7.6 earthquake in 1976 that was catastrophic. Hundreds of thousands of people died. And they know that the return period has essentially ended. And so in some ways, they're geologically overdue to have that type of catastrophic event happen. So getting those fault lines overlaid in a way that it was understood visually where they lie in respect to critical infrastructure, the sort of central corridor of the city where all of the economic activity, where universities and schools and hospitals are located, and really understanding what the potential impacts could be if that type of earthquake were to happen again today. And the analysis also had many other types of information, so we wanted to bring those in as data layers. We were able to do this in several different layers that could then be built up and put on top of each other. So I've kind of pulled them out separately so you can see them. This is looking at the generic seismic risk for the region. This is just a video output from Unity. And then being able to see, they wanted us to focus on that central corridor again, sort of understanding the risks to the international airport and the major critical infrastructure for the city. Then we added in the volcanic risk. This can be from toxic gases and volcanic ash from the volcanoes that are in the region. Again, sort of that same view to be able to see what would be the impact to the city. Because at the end of the day, it's about the impact on the people, right? Is understanding not just what is the sort of immediate effect, but also the socioeconomic impact to the area. So in that sense, it was important to bring in that additional context. NASA has a data set that is called the Socioeconomic Data and Applications Center, CDAC, which is hosted by Columbia University, which we were able to bring in as an additional layer to really show the high population density area. And you can see that here with the yellow fault lines. So really being able to see at a glance, all of a sudden now we can understand what the seismic risk is in terms of the population in that region. And this really starts to come to life when we layer that in. And of course, if you have a headset and you look at this in virtual reality, you can have sort of limitless ability to navigate around, turn layers on and off, have all of the full benefits of that full immersion experience. We found, though, that even with the limitations of the pandemic and working with people internationally, by providing them with these types of videos, they were still able to derive tremendous benefit from these visualizations. It wasn't necessary to have the virtual reality headset and have that fully immersive experience to still really be able to understand this data better and differently than what they had previously been using. Of course, we know that in VR or in the game engine, we have lots of parameters that we can play with. So this is something we've been working on, being able to change from day to night, being able to change the weather conditions, the cloud conditions, to look at different events and really provide that level of realism is something that we've gotten a lot of very positive feedback on. So you can kind of see how this now starts to come together. And we found out that Guatemala City was going to be hosting an actual earthquake simulation event that was going to take place during the day. So we started to put together some visual assets that would be able to be used by the city and by the international partners, by the United Nations, layering in relevant NASA data sets to be able to really provide some support for that event. So you can see, again, in this video, how that starts to all come together. We had hoped to be able to go and attend and bring VR headsets with us. That wasn't possible. So what we did end up doing was creating some 360 content and sending it to people's mobile devices. And we're really starting to dig into that as a great way to support using these visualizations with devices that people already have. While some people might say, oh, that's not really VR, we do think that the game engine itself, again, provides a lot of benefit when it comes to the interactivity and the limitless ability to look at different scenarios and layer these different types of data and have that better situational awareness and translation of critical information into something visual. So additionally, landslides are something that I had mentioned is a huge risk area for that region. Those can be triggered by earthquakes, but they can also be triggered by heavy rainfall events. And NASA has a really interesting data product for this. It's called the Global Landslide Nowcast, and it's basically a near real-time data product that's updated every 3 hours. It has many different types of input. And this is something that is available through that disasters geospatial portal. So we really had fun experimenting with bringing this into the Unity game platform and being able to understand, you know, can we look at something and basically have it be near real time and get that understanding of what the current conditions would be. So this was a huge success and milestone for this project to be able to bring that type of near real time data into the platform and, again, be able to look at this as one of the baby steps towards using a game engine as part of a decision support workflow for people who are using NASA data, other types of data sets to be able to make critical and timely decisions. Here you can see the generalized landslide risk for the region. This was from that multi-hazard reports from Salvaterra. So we can imagine how now, if we combine sort of generalized risk with that global landslide nowcast, we could get an updated portrait of where our risk areas are. Some of them for landslides are common sense. There's a lot of deep ravines and such in the Guatemala City region, but it can certainly also help these decision makers pinpoint where they would need to allocate resources. Similarly, for floods, we can layer in these types of information because we know, obviously, that these events occur. Climate change is worsening them. So we can look at the generalized risk for flooding in the region, again, as a layer that could be toggled on and off to be able to really understand what the potential impacts are. And then you could add in a layer for specific events. So Guatemala experienced last year double hurricanes that caused a lot of flooding and devastation in some of the more rural regions, and being able to put those in as layers to really be able to make that leap, right? Just not from the data itself looked at numerically, but to an actual decision that can be data driven. We think that this is a way to really help some of these regions to improve readiness and resilience by giving them access to scientific data and information in a format that is more understandable. You no longer need to have a research or scientific background to be able to interpret the data if you can see it translated into this visual format. So here you can see pulled out separately some of these different layers for the regional risk, and being able to see how that can then be built up inside the game engine to provide real situational awareness and understanding. And that all comes together in a video like this, or again, if you were in a headset or in the game engine itself, to be able to really start to have the navigational capability and be able to move around yourself, toggle different data layers on and off, be able to look at specific key infrastructure and holdings. If we had the information for the subterranean critical infrastructure, such as oil and gas and electrical, we can add that in as a layer as well. So again, you're seeing the yellow fault lines layered on top of the 3D buildings from the Guatemala city government, and then some of these additional data layers that were brought in into Unity to provide that overall risk context. What was very exciting for us, and I mentioned, we found out that they were actually going to be holding a simulation event in Guatemala City. And so we found out that this was an opportunity to put some of our R&D and some of these conceptual ideas into practice. So on February 4th, the Central American Earthquake Simulation Drill was held. Guatemala City hosted for 7 other Central American countries. Also, the United Nations was part of this. NASA Disasters sent a representative to Guatemala City to also provide support. And you can see in this image here inside of the Emergency Operations Center, NAVTECA's visualization was actually part of creating that scenario, helping all of the different participants to understand what was the overall risk for the region. And we also provided additional video output from Unity to show them where the simulated earthquake was occurring, so they could see the depth, and relevant information to sort of set the stage for the drills that were held that day. It was very interesting also to kind of follow along in real time as they were conducting these drills. They had actual teams out in the field, and again, they were coming from across 7 different countries, and the United Nations also had teams there as well, and going through the actual simulation of what would occur if an earthquake of that magnitude, were to happen. And so they were live tweeting throughout this event, and we were, getting tagged, and NASA was getting tagged on these things. So it's really an interesting exercise, and I think showed the power of these type of technologies to be able to do something really meaningful, even during a pandemic, even working remotely. It was a really cool use case to be able to be part of that. So kind of coming back to that original idea of like, we have all of this information that's out there, the remote sensing, the maps, the imagery, the Earth observation data, the reports, model output, and now really being able to bring them together into a common visual framework, whether it's virtual, augmented, or mixed reality, or even just the game engine itself, whether it's 360 content that we can push out to people's mobile devices, that this really can be an incredible visual tool to bring people together from lots of different backgrounds, lots of different types of stakeholders, and be able to give them a collaborative environment to be able to understand that information. So I wanted to also show you sort of how that's coming together into some of our current work. And we continue to really explore this as a potential decision-making tool. This is some current things that we're working on for Puerto Rico to look at flooding and seismic activity that have been occurring in the southwestern region, sort of also taking that multi-hazard risk analysis as a basis of how to build up some of the layers. So you're seeing from the screen grab actually the beginnings of this tool from inside Unity, with the idea that people would be able to put together a timeline and storytelling, be able to layer in information so it no longer requires somebody live explaining it to you, but that different practitioners, even again without necessarily the scientific background, can start to build this for themselves to be able to bring in the relevant data sets. And then we're also playing around with being able to bring in photos and video and other geospatially located assets that you can then layer in to be able to have both the virtual framework, but also the element of realism, being able to take information from out in the field and actually look at it in situ to be able to make that comparison. So again, for people who are making decisions, to be able to take data and really translate it into something actionable, we think holds a lot of potential for the future. So let me forward this to where we see that. So here you can see an image of a flooded highway and then being able to find that actual location and line it up correctly. So here you can see in the virtual environment, stop it for a sec. You can see in the virtual environment, we have this correctly located, and then to be able to see layered on top actual data from a real event and potentially compare that to some of our overall risk analysis and other information could be a very powerful tool for the future. We're also playing around with additional interfaces such as natural language and other AI components to be able to bring additional layers of support to a tool like this. So we're very excited about where the future is going in terms of being able to use this type of technology to really help the humanitarian and disaster community to be able to use the data that's already out there and to be able to use it in a way that's actionable. Overall, we think that this is something that can really help to increase the resiliency that cities and states and countries are going to need to develop for the onslaught of extreme weather, disasters, and of course being made worse by climate change. That this is a way to really visualize and plan for these events, to be able to collaborate with other outside stakeholder groups, and that this can be something that's quite beneficial. This is my contact information, so please feel free to reach out. Let's see, to either my NASA or NAVTECA email if you'd like more information. And if you're interested in the disasters data, there's also a link to the portal.
All right, great presentation. Any questions from anybody around the loop? All right, somebody has their hand up, or they had their hand up. Kenji?
Yeah, quick question. It looks you're using Unity, your visualization. How are you handling the double precision? Because it looks like you've got a full Earth model there.
Yeah, we've built a lot of custom shaders and meshes. And then are you talking about the precision in terms of like the actual geospatial location?
Yeah.
Yeah, some of it has been a little bit fiddly. I could follow up with you separately because it's a pretty in-depth discussion, I think, of some of the things that we found that have worked and haven't worked.
Yeah. Okay.
But yeah, it hasn't necessarily been straightforward.
Okay. And a quick other question. You said that you were importing the data automatically from the disaster portal. Did you guys write a tool that lets you, because the data is there on the web, but are you pulling that data in automatically and mapping it?
Yes. Yeah. So we wrote that, and we've been exploring with other APIs of what, essentially what else could we bring in. But the cool thing is, like, for example, the global landslide nowcast example that I gave you, that's actually updated every 3 hours. So, now with the tool that we've written, you could actually go into VR every 3 hours and look at sort of updated landslide risk for anywhere in the world, since it's a global data set.
Thank you.
Yeah, I look forward to following up with you.
Yeah, excellent presentation. I'd definitely like to follow up with you offline. I've been talking to NVIDIA about their Earth 2 project, where the ultimate objective is to create a digital twin of the Earth.
Yes.
So tying in some of these real-time data tools you mentioned would be extremely useful for that.
Yeah, absolutely. I think we've built up quite a bit of expertise about how to do that, and doing it before that, digital twin terminology even existed. So It's really exciting to see what people are doing with that. And I know there's a lot of work being done in Europe as well to create digital twins. So yeah, that's definitely a follow-up.
Awesome.
Thank you.
All right, any final questions? If not, let's go to our next presenter, Ryan.